So we're going to start into chapter 4, and this is a doozy of a chapter. You kind of get a lot of things included in this chapter. So take it slow, slide by slide, topic by topic, and let's go. So we're going to talk about chemical reactions in this chapter, and we're going to start out by talking about equations, which is the way to write in a reaction in terms of the symbols. So a chemical equation is the symbolic representation of a chemical reaction in terms of chemical formulas. So for example, if I said let's burn or let's react sodium and chlorine together to give us sodium chloride, I would write this as sodium, 2 sodium, we'll talk about the 2 later, plus chlorine. Chlorine, remember, is one of those 7 diatomic elements that always appear as diatomics and never appear alone as the element. And then on the right-hand side, we have sodium chloride, salt. So the reactants are the materials on the left, the starting substances, and then the arrow means yields or forms, and then the formulas on the right are the products. Okay, a lot of times we want to clarify a little bit better, and so a lot of times you'll see symbols indicating the phase of a substance. So like you can see here, solid, liquid, gas. Aqueous, AQ, stands for dissolved in water. Let me write that here. So if we take the reaction that we just looked at, sodium as a solid plus chlorine as a gas will react to give us sodium chloride as a solid. Sometimes we see other terms. Sometimes we'll see a triangle over the arrow, and that represents means heat, usually, if we're heating something. You might also see other kinds of arrows and things like that as well. Now, we've talked about the law of conservation of mass earlier in another chapter, and that just means that matter is neither created nor destroyed. So that means the easiest way to represent that says that the total number of atoms of each kind are equal on both sides of a chemical equation. So if they don't match, then we have to balance the equation. So if you look at this equation right here, and you will see that we have one carbon on this side, 1 carbon on this side, 4 hydrogen on this side, but we only have 2 on this side. And then we have 2 oxygen on the left and 2 plus 1 more on the right. So this does not follow the law of conservation of mass, and so this is not the true reaction. We have to balance it. And this is the combustion of methane to produce carbon dioxide and water. So let's look at what we need to do to balance. All right, so if you notice here, what we do is we put we have 4 hydrogen over here on the left, and we only have 2. So in order to get 4 hydrogen on the right, we multiply by 2, or in other words, we multiply. We have 2 waters rather than 1. So now you can see we have 1, 2, 3, 4 hydrogen, and we have 1, 2, 3, 4 hydrogen. And now on the right, we have 1, 2, 3, 4, the 4 oxygen, and we have originally we had 2 oxygen, so if we double that, 2 in front of it, now we have 1, 2, 3, 4 oxygen. So now this equation is balanced. So we have the same number of atoms of each kind on both sides. The numbers, of course, in front are called coefficients, just like they are in algebra. So let's look at a step-by-step example, very, very simple example about how to balance an equation. So you can see here that I've gone ahead and drawn out the molecules. I think this is a bit extreme. You probably don't need to do that, but I've got hydrogen gas, so that's one of those diatomic elements. I've got oxygen gas, and they're forming water. So already I can see that I only have one oxygen on this side and I have two on this side. So the only way I can get more oxygen, I can't just go and add another oxygen over here, because if I do that, then I'm changing the molecule. This is something different. So I can't similarly there. I can't write a 2 there. That would not be correct. So what I need to do, the only way I can get another oxygen is to double how many waters I have. So I put a 2 in front of that, and now I have 2 whole water molecules. Well, what's happened here? Now I have 1, 2, 3, 4 hydrogen, and on the left I only have 2. But again, if I double it, so here you can see I doubled it. Now I have 4 hydrogen, 2 oxygen, 2 oxygen, and this reaction is now balanced. I need 2 hydrogen plus 1 oxygen will give me 2 waters. So here are some guidelines for the best way to balance equations. There's a lot of right ways. I suppose there's a wrong way to do it, but there's many right ways. So it's not if you have a little bit of a different way than someone else, it's not a problem. But these are some guidelines to help you decide what to do first if you're not sure where to start. So first, start with the most complicated molecule. You know, if you've got something real complicated, start to balance that. Or just another way of thinking about it, find and balance the elements that only appear in one compound on each side. So if you've got something that has one element in more than one compound, like we looked at that CO2 plus H2O, they both had oxygen. Sometimes that's better to leave till the end, because if you start fixing it to match with one thing, and then it'll mess up something else. So it's kind of good to wait if something appears on in more than one compound on any one side. If an atom occurs by itself, like just magnesium or sodium, or even elemental like O2 or H2, but it's not combined with any other element, that's a really good one to save till last, because it's easy to balance without messing up anything else. It's really important, again, like I said, to only change coefficients. Never change the formulas. You can't change the formulas, because then you're changing the reaction. A little bit more, drill down a little bit more, coefficients should always be the smallest possible number. So whenever you're looking at your answer, you might want to just take a minute and see if it's in its lowest terms. If not, you want to reduce it down. And when we have polyatomic ions, sometimes they can be counted as one unit. If they show up as the same on both sides, I would count it as a unit. It makes it a little bit easier. So let's do a few more examples. So methane is the main ingredient in natural gas. When it reacts with oxygen, so CH4 gas, O2, this is the one we actually looked at just a minute ago, but let's kind of go through it step by step. So CH4 plus O2 gives me CO2 plus H2O. Sometimes, especially if you're a beginner at doing this, it helps to kind of write out the different elements. So right now in this unbalanced equation, I have 1 carbon, I have 4 hydrogen, 1 times 4 is 4, and then I have 2 oxygen, 1 times 2 is 2. On the right-hand side, again, I have 1 carbon. The reason why I have them separate, you'll see, because the oxygen shows up in 2 places. I have 2 hydrogen, and then here I have 2 oxygen in the CO2, and then 1 in the water, so I have a total of 3 oxygen. Okay. Obviously, I'm not balanced. Now, where do I start? If you use the guidelines, well, first of all, you don't want to start with carbon because they're already balanced. And you probably don't want to start with oxygen because, like I said, it shows up in 2 places. And so you just probably want to wait. So I would start with the hydrogen. So if I balance the hydrogen, the best thing I can do is to multiply the water by 2. And so now I have 4 hydrogen. But also notice, Well, on this side, yeah, I have 2 times 1. I have two oxygen on the left, 4 hydrogen, 1 carbon. I still, on the right, I have 1 carbon, 2 oxygen from the CO2. And then now that I've multiplied this by 2, I also have 2 oxygen. So now I have 4 oxygen on the right. So I've balanced my carbon, I've balanced my hydrogen. I still haven't balanced my oxygen, but actually you can see it's probably easier now to balance it because I have 4 on the right, 2 on the left. So I can add a 2 in front of the oxygen, and now they're balanced. So like I said, if it helps you to write it out like this, the thing I would definitely recommend is not to just have one number. If you've got the element in 2, I would keep them separate. So because if you just change 1, you know, so you have the 2 plus 2 is 4, and we just changed this one, we didn't change this one, so it makes it harder to keep track if you just add them together and don't really pay attention where they're coming from. All right, let's look at a few more examples. All right, let's determine if the following equations are balanced. If not, add coefficients to balance them. So if we start here with aluminum plus iron oxide, okay, Fe3O4, and then we've got iron and aluminum oxide. So I've gone ahead and written that. I've got 1 aluminum, I've got 3 iron and 4 oxygen. On the right, I've got 1 iron, 2 aluminum, and 3 oxygen. So I'm not balanced on anything. So one of the guidelines we said was to save something. If it's all by itself, save that for last. So the first thing I'm going to do is balance my oxygen. So if I've got 4 on the left and 3 on the right, my least common multiple is 12. So I need to multiply this one by 3. And that gives me 9 iron and 12 oxygen. And then if I multiply the right by 4, that gives me again 12 oxygen, my least common multiple. And now I have 8 aluminum. So I'm still not balanced, but hopefully you can see that this is very easy. If I need 8 aluminum, I can put an 8 in front of here. And if I need, that'll change that to 8. And if I need 9 irons, I can put a 9 in front of there, which will change that to 9, and then I'm balanced. So I think that's on the next slide. Yep. Here's an example. Balance the following equation. O2 plus SO2 gives me SO3. This one's a little bit more complicated because, as you can see on the left, I have 4 oxygen, 2 plus 2. On the right, I have 3. And I have 1, my sulfurs are already balanced. So I'm going to have to balance my oxygen. But the fact that these are in different compounds makes it a little bit harder. We don't want, it's probably not going to work to find the least common multiple. You could, and we can do it 2 different ways. So let's go ahead and do it that way. So if I want to find least common multiple, I'm going to try to get 12 on the right hand side, but that makes it harder. So I'm going to multiply this by 4. But notice if I just keep doing it, if I multiply this by 4, I'm still going to keep being unbalanced. So the fact that I've multiplied that by 4 and made that 12, the next thing I want to do first is I'm going to go ahead and balance my S's. So I'm going to put a 4 in front of my SO2. What does that make? I've got 4 here, 4 here. I've got 12 oxygen. Here I have 4 times 2, or 8. And then I need 4 more, so I can put a 2 in front of there. Now notice that this is not the lowest ratio here, so I'll probably want to reduce it down. So I'd have 1, 2, and 2. So that's one way to do it. You just have to beware, because if you start trying to use least common multiple here, you'll go round and round in circles. Another way down here that I did it is I said, well, if nothing else, I definitely need more oxygen on the right. I had 3 and I need more. So one thing I can just do is try doubling this. So that's what I did here. I just doubled it. and I got 6 oxygen. And then since I doubled the sulfur, I want to go ahead and double that. And when I double that, now I have 4, 2 here plus another 4 gives me 6, and so my oxygens are balanced. So that's just another way to do it. So it's what I'm pointing out is that there's more than one right way to do something. And so there's the balanced equation. Sometimes when you have your polyatomics, like I said, this is a polyatomic NO2, or I'm sorry, NO3. You've got one of them on the left, and you've got 2 of them on the right. You certainly can balance individual atoms, but sometimes it's a little easier if you because then that's one less thing that you have to balance. So a lot of these kind of reactions are pretty straightforward. There's no guideline for saying how to start this one because nothing's balanced. Well, the silver's balanced and the magnesium's balanced, but the nitrate and the chlorine are not. So just start balancing something. So it looks like the first thing I did was go ahead and balance the nitrate. Since I had 2 on the right and 1 on the left, I put a 2 in front of the silver. Now the main thing is don't forget to distribute. So I did definitely change the nitrate, which is what I wanted to do. It matches, but I also doubled the silver. So now my silvers aren't balanced. So a lot of times what's really a good way to do this is go ahead and fix something, and then if it messes something else up, go next and fix that. So then what I did, so I put the 2 here. Then what I did is put a 2 in front of the silver to rematch up the silver. They were matched, but then when I put the 2 for the nitrate here, it messed up the silver. So now the silver was not balanced. So if I put a 2 there, it balances the silver, but then it also gives me 2 chlorides, which is what I needed. So actually it worked out very well. So these kind of reactions often balance. If you just pick something, if you're not sure, just pick something and start balancing it, and then balance the next one and the next one until you're done. Sometimes we can use fractions as coefficients, and so I wanted to show you an example of that. Now probably most people don't like fractions and they'll probably just do whole numbers, and either one is fine, but I did want to point out to you because sometimes textbooks like to put the fractions in, and so I didn't want people to be totally startled by that. So if we look at this example, we've got 4 carbon on the left and only 1 on the right. We have 2 oxygen on the left and we have 10 hydrogen on the right. Only 2 hydrogen and then 2 plus 1 more, 3 oxygen. So our oxygen, nothing's balanced. So I'm going to leave oxygen for last because I said that if it shows up in more than one place, it's probably best to leave that and see what happens when you do the other ones, and then you can fix it. So the other guideline was if it's all by itself, it can be easily fixed. So that's why I'm going to leave oxygen for last. So the first thing I'm going to do is I'm going to balance my carbons by putting a 4 in front of the carbon. So now I have 4 carbons, and now I have 8 oxygen from the CO2. And then I also, it looks like I did 2 things at once. I also balanced the hydrogen, so I have 10 on the left, 2 on the right, so I multiplied that by 5. So I have 10 hydrogen. And now I have the oxygen, I have 8 plus 5 is 13 oxygen. So I've balanced my carbon and my hydrogen, but my oxygen are not balanced. And as I said earlier, it's really easy to balance it if it's all by itself, but what's weird with these diatomic elements is that generally you need an even number. So 13 and 2, everything else is balanced, but I can't balance these. So there's 2 ways you can do it. I think that's on the next slide. One thing you can do is you can write 13 halves in front of the oxygen. So I had 13 over here, and then if I put 13 divided by 2 on the left, notice that 13 divided by 2 times 2 will give me 13 again, so now I'm balanced. So that's one thing you'll often see an improper fraction in terms of halves if they're in front of a diatomic element. The other way you could do it instead is, since you had the 13 earlier, you could just write 13 here. But notice that if you put 13 in front, what happens? You've got 26 oxygen. So you kind of, if you do it that way, what you have to do, so you're kind of doubling your oxygen, and everything else was already balanced. So what you need to do is go ahead and double everything out. So you put a 2 here, 8 and 20. You put you double that, so you have 8 CO2 and 10 H2O. So you've doubled everything, which is very similar. If you have the fraction, you can clear out the fraction by multiplying by 2. So either way you think of it, if you want whole numbers, everything has to double, or it's appropriate or allowed to put a fraction. All right, so let's just try a few more. Balance the following equation. So let's look at this one. So right now I've got, I'm going to write it up here. I've got 2 oxygen, and I've got 1 phosphorus, and I've got 3 chlorines. On the right, I have 1 phosphorus, and I have 3 chlorines, but I only have 1 oxygen. So if I want to have 2, I need to put a 2 in front of here. That doubles everything. Now my oxygens are balanced, but my P's are not, so I need 2 P's on the left, so I'll put a 2 there, and then I'll need 6 Cl's. So that 2 will take care of that. So that's balanced. I'm going to go ahead and erase my musings here and just have the answer. All right. All right, the next one. So let's see, we've got on the left-hand side, we have 4 P's, we have 2 N's, and we have 1 O. On the right-hand side, we have 4 P's, we have 2 N's, and we have 6 O's. So again, 2 out of the 3 are balanced. So I'm going to have to balance my O's. And so if I need 6 O's here, I have to put a 6 in front of that. So now I have 6 O's, but I've also now got 12 nitrogen. So if I want to get 12 on the right, I'm going to have to multiply that by 6. And I believe the P's are still balanced, so that fixed everything. All right, this one's probably a little harder. Those 2 were fairly easy, but let's erase this so I don't get things confused. All right, so here we have arsenic 2, sulfur 3, and oxygen 2. On the right-hand side, we have arsenic 2, sulfur 1, and then oxygen we have 3 plus 2, so we have 5. But remember, we can change these independently, so we don't want to think in terms of 5. We can think in terms of 3s and 2s and see how things balance. So my arsenics are already balanced, but my sulfurs are not. So let me go ahead and balance my sulfur. And again, I'm going to leave oxygen for last because it's going to alter. So now I've got 6 on the right. So now I have 6 plus 3 is 9. Well, I'm still not balanced, but I can do my fraction. So I can do 9 halves. So this would be 9 halves would give me 9 oxygen, 3 sulfurs, and here I have 6 plus 3 is 9, and then my 2 arsenics. Or if you prefer, you can multiply everything by 2, cross out the fraction, and that gives me my balance. So either of those answers would be correct. And finally, I've got one more. Let's erase these. This one you have to be careful with because even though there is a polyatomic, it doesn't appear as a polyatomic on both sides. So I'm just going to do each element individually. So I've got 3 calciums. I've got, now be careful here because that parentheses means there's 2 of these whole things. So there's 2 phosphorus and 8 oxygen. But I also have this on the left-hand side, so I have another, so I have 3 hydrogen, and I have another phosphorus, and I have 4 more oxygen, so I have 12 oxygen altogether. I have 8 plus 4 more. On the right-hand side, I've just got one big thing, so I've only got 1 calcium. I can see how this is going. I've got 2 times 2, I've got 4 hydrogen. Let me do it in order that I have the other ones. Let's do phosphorus first. So I've got 2 times 1 or 2 phosphorus, and then if I do my oxygen, I've got 2 times 4 or 8 oxygen, and then I have hydrogen. 2 times 2 is 4 hydrogen. So you can see that the only thing that's nothing's balanced. And unfortunately, since this only has one product, that's the only thing we can change. So hopefully, let's start with the calcium. We have 3 over here and we need 3 here. So if I put a 3 there, what's going to happen? That changes that to 3. That changes that to 6. 2 times 3 is 6. This changes 8 times 3 is 24. And then 2 times 2 times 3 will give me 12 hydrogen. All right, so my calcium are unbalanced. My phosphorus are not, and my oxygen are not. Now, I don't want to mess with this one on the left anymore because that's the only thing that keeps my calcium balanced. So I'm going to see if adjusting the one on the second compound here will fix anything. So since hydrogen, this is the only one that has hydrogen, I think we can figure this out. Since there's 12 on the right and 3 on the left, we need to multiply by 4. So if I put a 4 in front of there, I have 12. Then I have phosphorus, I have 4 plus 2. 2 plus another 4 will give me 6. And that's good, that matches. And then I've got my 12 hydrogen, and then 4 times 4 is 16 oxygen, so I have 8 plus 16 is 24. So that balances it. So sometimes you have to think through, you know, this is the only thing I can fix on the right, so I had to fix the calciums. Now I don't want to mess up the calcium anymore, so I'm going to have to see how that works. So a lot of times it just takes some practice or just some thinking. So that's balancing equations.